Oh, hello. I didn't see you there. Welcome to another edition of Algebra 2 with Mr. Peterson. Today we'll be looking at the square root property and completing the square. Your learning goal today should be you should be able to find the roots of a quadratic equation by either using the square root property or completing the square. And like I said, we're going to look at just the kind of first part of completing the square, which is what are the mechanics of completing the square. The next video will go into actually how is it very useful, and it is very useful. So first, let's write this down in our notes. Go ahead and pause the video. Okay, so odds are, if you've made it this far into quadratics, you've realized that quadratics are the result of squaring something. So it makes sense that we could take the square root of both sides, and that would give us our roots. All right, so let's look at an application of that. So here's example 1a. Solve the equation 3x squared take away 4 is equal to 68. So our first step here is going to be to add 4 to both sides. Add 4 to both sides. So at this point we have 3x squared is equal to 72. The next step would be to divide by 3 on both sides, and we get x squared is equal to 3 goes into 7 twice, with 1 remaining. 3 goes into 12 4 times. So x squared is equal to 24. So the square root property says we can just take the square root of both sides. So that means that x is equal to, and then remember your ideas from Algebra 1, if we're going to take the square root, it's plus or minus the square root of 24. But this is not in simplest radical form. 24 has a perfect square as one of its factors, 4 of course. So x is equal to plus or minus the square root of 4 times 6, which is equal to plus or minus 2 times the square root of 6. Which means that we have two roots here, a positive 2 square root of 6 and a negative 2 square root of 6. All right, let's look at another example. X squared, take away 10x plus 25 equals 27. All right, so hopefully we notice that this right here is a perfect square trinomial because we have a square here and we have a square here. So what we're going to factor this as x minus 5, and then we're going to square that, is equal to 27. All right. So now we can take the square root of both sides. We'll take the square root of this side and of this side. And when we do that, put that together, we have x minus 5 is equal to the square root of 27. And we'll just do a little mini problem here. This is really the square root of 3 times 9. So 27 is really 3 times the square root of 3, because this 3 is going to come out, that 9 is going to come out in front as a 3. So if x minus 5 is equal to 3 times the square root of 3, so what we're going to do now is we're going to keep solving for x. We're going to add 5 to both sides. Oh, I left off a key step. We got to remember that this is plus or minus 3 times the square root of 3. So we'll go ahead and add our 5. So I'll come up here out of room. Our final answer is x is equal to 5 plus or minus 3 times the square root of 3. And so just to kind of use your calculator here, if you wanted to find the roots, you would have 5 plus the square root of 3, and that's one of our roots, 6.73 going on. And then we would also do 5, I made a mistake right there, 5 plus 3 times the square root of 3, 10.196, and then we would also have 5 minus 3 times the square root of 3. Negative 0.19 is another root. So Square root property, really kind of a cool trick here to make some of these easier. Why don't you guys try this one and try this one. All right, now we're going to look at the idea of completing the square, which is kind of an important idea. What we have right here is we have the kind of intro to a quadratic function. We have x squared, and then we have plus a 6x. All right, well, as you can see here, like we were talking about, all quadratics are the results of perfect squares. And so you can kind of see here that this is not a perfect square because we're missing this part down here. See, now that I've added that square, you can see that we now have all of our parts make up a square. So the idea here is that we can take and rewrite this expression as a perfect square trinomial. And the way that we do that, is we have to take this b term right here, and we have to divide it by 2 and then square it. All right, so let's go ahead and do that. If we take 6 and divide it by 2 and then square it, well, 6 divided by 2 is 3. 3 squared is 9. That means I should be adding 9 in this space right here. And if you look, kind of drawn it up here, we add our 1s. Whoa. There it is now. We've now completed the square. You can see we've got the full idea here. So our expression that we would now rewrite is x squared. We'll go back to the pen. X squared plus 6x plus 9. And we've now completed the square. It's important to note that these expressions are not equivalent. They're not equivalent to each other. However, in the next video, we'll talk about how we can use this idea of completing the square to solve any quadratic problem. Okay, so here are the steps for completing the square. Go ahead and write those down. Okay, and let's do 2 quick examples, and then we'll be done for this video. So again, this example is just what would we do, complete the square for each expression, and then write the resulting expression as a binomial squared. All right, so remember, our first step is to figure out, okay, what is half of that? So -2, half of our b term, and then we want to square it. All right, well, -2 divided by 2 is -1. A -1 squared is +1. So our perfect square trinomial that we would write is x squared minus 2x plus 1. That equals 1 over here, just to be clear. All right, but then remember, they wanted us to rewrite this as a binomial. Rewrite the resulting expression, not equal, resulting expression as a binomial squared. Okay, so we would have x plus 1, excuse me, we have x minus 1 squared is our resulting binomial expression. And that's all they wanted us to do here. Rewrite the resulting expression as a binomial. There we go, or as a binomial squared. All right, let's look at this one. Complete the square, rewrite as a binomial squared. Okay, so remember, we want to take half of b, so 5 divided by 2, and we want to square it. So 5 divided by 2, that's not really going to help us out. And divide nice and easy. So we're just going to leave it 5 over 2, but we're going to square it. So remember our properties of exponents. This is really 5 squared over 2 squared, which is going to be 25 over 4. So what that means is we now have the expression x squared plus 5x plus 25 over 4. And now we want to rewrite it so that it is the product of a binomial squared. So what we would have is we would have x plus 5 over 2 squared. And there's our resulting expression. Remember, always a good idea just to maybe check to make sure you did it right. And I'll just go ahead and check it here in a different color. We're going to check it by foiling it. X plus 5 over 2. This would give us our x squared. This would give us 5 halves x. This would give us 5 halves of x. And this would give us 25 fourths. Then you combine these for 5x. And then x squared plus 5x plus 25 over 4. All right, so try this one, and this one, and this one. All right, tomorrow's video we'll look at how can we use completing the square to help us solve quadratic equations.